Okay, Murari, you had a question about this integral of log of 1 plus sine squared x divided by cos squared x dx. Now, the first thing we have to keep in mind is that this is not a combination of trigonometric functions. Rather, it is a combination of a composite function, that is a logarithmic function of a trigonometric function in the numerator, and the cos squared x, which is a pure trigonometric function in the denominator. So as soon as we recognize that there is a logarithmic function and a trigonometric function, and also that if we bring the cos squared x into the numerator, it becomes secant squared x, we should be thinking about integrating by parts. And so let's see what happens when we do that. So here's our integral again, integral log of 1 plus sine squared x by cos squared x dx, and as I said, we bring the cos squared x to the numerator as a secant squared x. Now treating the log function as the first part, which is what the IIT order prescribes to us, we get log of 1 plus sine squared x into integral of secant squared x dx minus integral of the derivative of log of 1 plus sine squared x times the integral of secant squared x dx. Now the integral of secant squared x is very simple, that's tan x. So I get log of 1 plus sine squared x into tan x, and then the derivative of log of 1 plus sine squared x, I need to use the chain rule, and so I get 1 divided by 1 plus sine squared x into the derivative of 1 plus sine squared x, which is simply 2 sine x cos x, and then the integral of secant squared x also is up there. So now moving things around, I get tan x log 1 plus sine squared x, and then I get minus 2 times the integral of sine squared x divided by 1 plus sine squared x dx. So I keep that the thing that we already integrated in the first term as it is, and then the integrand which remains here, I write that as 1 minus 1 plus 1 minus 1 divided by 1 plus sine squared x. That's pretty straightforward. I can bring this 1 out, I can integrate that, that becomes just minus 2x, and then I have twice the integral of, I would have had 1 divided by 1 plus sine squared x, but I can easily divide the numerator and the denominator by cos squared x, which is simply multiplying it by secant squared x, and so I would get secant squared x divided by secant squared x plus tan squared x dx. So now let's go back to that term. I get this secant squared x is just tan squared x plus 1. So I write that there. And I get, so this integrand becomes secant squared x divided by tan squared x plus half. Okay? Because I would have had 2 tan squared x, but there was a 2 just before the integral also. So we can get rid of that. Now I make the substitution tan x is equal to t, which gives me secant squared x dx is dt. And so that integral becomes integral of dt divided by t squared plus half. That's a standard result. So I get 1 divided by 1 by root 2 tan inverse t divided by 1 by root 2. And then just simplifying everything and replacing t with tan x, we get I is equal to tan x log 1 plus sine squared x minus 2x plus root 2 tan inverse of root 2 tan x, and then we add the integration constant.